Today we'll be dealing with periodic table, and this we will study periodic property, which is electronegativity. Now, what is this electronegativity? It is a measure of tendency of an element to attract the electron towards itself when it is in a bonded state. So I have highlighted that when it is in a bonded state. When it will be in a bonded state, at that time only it will be called electronegativity. So the definition here is a measure of tendency of an element to attract electrons, or we can say the shared pair of electrons towards itself in a covalently bonded molecule. Example: if we consider a covalently bonded molecule like HCl, we say that is a polar in nature, with hydrogen is delta positive, chlorine is delta negative. So in this we say that the EN of chlorine is more, means the shared pair of electrons are shifted slightly towards chlorine. That's why it is getting partial negative charge. Means the force of chlorine to attack the electrons, so the shared pair of electrons towards itself is more. That's why we can say that the electronegativity of chlorine is more. What we will see next is factors affecting electronegativity. Now, what are the factors affecting electronegativity? We can derive them on the basis of logic also. But we can say more is the ionization potential or ionization energy, and more will be the electronegativity. We can say more is the electron affinity, then we can say more is the electronegativity. More is the ionization potential as well as electron affinity, then we can say if the element is having more of ionization potential and electron affinity, then we can say it is having more electronegativity. Thus this property is depending upon the ionization potential as well as electron affinity. Now we can relate electronegativity to atomic size also. You can say atomic size is inversely proportional to electronegativity. Now what does this mean? This means that more the atomic size, if the atomic size is more, then electronegativity will be less. If the electronegativity will be more, if the atomic size is less, then the electronegativity will be more. This is what is called the inversely proportional relation. If the units are inversely proportional, then when one thing increases, another thing decreases. Third factor we can say is the oxidation state. More is the oxidation state of an element, more is the electronegativity. So we can relate them as oxidation state is directly proportional to electronegativity. Means more the oxidation state, more the electronegativity. You can say like manganese exists in two oxidation states. One is Mn plus 2, other is Mn plus 7. So in this, if we compare the electronegativities, then Mn plus 7 will be having more electronegativity than Mn plus 2. Example, in its compounds like MnO2, MnO3, in these compounds MnO3 will be having more electronegativity than MnO2. Why? Because if we calculate the oxidation number of oxidation state of Mn, then it is coming more in O3 and less in O2. We can also relate it to nuclear charge. More the nuclear charge, more will the En. Why? It is because more the nuclear charge, the nucleus will attract the outermost electrons as well as the shared pair of electrons by more force. Thus, nuclear charge and En are directly proportional. Means if the nuclear charge is more, then an En tends to be more, electronegativity tends to be more. With increasing nuclear charge, force of attraction between nucleus and the valence electron increase, and therefore the electronegativity value increase. Next factor which is affecting En is percentage S character. We know about hybrid orbitals. In hybrid orbitals, if the percentage S character increase, then the En tends to increase. Example, if we consider following hybridization like sp3, sp2 and sp, in this if we consider the order of En, then that will be this. sp will be having greatest percentage S character, that is 50%. So it will be having highest En. sp2 will be having slightly less S character, that is 33%. So it is having less En than sp. And sp3 is having only about 25% S character. So it is having more or less En than sp2. So we can represent S like this. En increases. Now we will understand this with the help of example. Like in methane, central carbon is attached to 4 hydrogen bonds. So the hybridization of central carbon will be sp3. While in ethene, the hybridization of carbon is 1, 2, 3, that is sp2. And in ethine, the hybridization of central carbon of the carbon atom is sp. And thus the electronegativity order will be this: ethine, then ethylene or ethene, and then methane. The maximum En will be having the carbon which is in acetylene or ethine. Next we'll see strand in periodic table. First we'll consider it in a group. In a group, on going down the group from top to bottom, En tends to decrease. The reason being, nuclear charge increase, but the electrons are added in new shells. Thus the outermost electron is experiencing less force than expected because newer shells are being added. Thus the electrons are attracted by less force. Thus the electronegativity tends to decrease on going top to bottom in a group. While in a period, if we consider a strand, then on going left to right, generally the En increases. Why so? First reason is nuclear charge increases by one unit, and the electrons are added in the same shell. In the same shell, the overall effect being the nuclear charge dominates over this addition of electron, and generally the electronegativity increases. Next, we'll consider the differences in electron affinity, or we call it as electron gain enthalpy also, as I've discussed earlier, and electronegativity. Now, why we are studying this? The reason being because both the properties represent the attraction of electrons toward itself. That's why we should know about their difference. So, the difference between EA and EN. What is EA? As we have discussed before, it is a tendency of an isolated atom to attract the shared pair of electrons toward itself. But what is EN? EN is the tendency of an atom in a combined state to attract the electrons towards itself. Means this is in a combined state, and EA was in an isolated state. In EA, we took the atom in isolated form. In this, the component is present in the element is present in the form of a molecule in a bonded state, in a covalently bonded state. The tendency of an atom in a combined state, that is, in a molecule to attract the shared pair of electrons towards itself. Now, what is the second point for difference? Second point will be electron gain enthalpy can be measured experimentally. Like by doing experiment, we can know this. By electronegativity, it is a relative number and cannot be determined experimentally. It means EN cannot be determined experimentally because it is a relative number. A third point will be, as we are saying that electron gain enthalpy is the amount of energy released or gained So it will be having units, and those are electron volt per atom per atom. And for 1 mole, it will be roughly about kilojoule per mole. While in En, it is having no unit. Next periodic property which we will be considering, which undergoes a regular change in periodic table, is nature of oxides. Going left to right in a periodic table, the nature of oxides changes from basic to acidic. This will be doing it with the help of example. Na2, MgO, Al2O3, SiO2, the third ring, P2O5, Cl2O7. So what will happen is, on going left to right in a periodic table, the nature of oxides gradually changes from basic, in case of alkyl alkyne to acidic. Means the Cl2O7 is acidic oxide, Na2MgO are basic oxides. While if we consider the nature of oxides in the same metals, when a metal form more than one oxide, like N2O, NO, N2O3, NO2, and so in this V to N2O5, in this we see that the percent of oxygen is varying, and it is a direct relation that more is the percentage of oxygen, more is the acidic nature. So we can see on going top to bottom, acidic nature is increasing because percentage of oxygen is increasing. Also we can relate to it to oxidation state. We can consider in case of Mn also, as Mn is forming a lot of oxides. Mn, Mn2O3, MnO2, MnO3, Mn2O7. So the nature of oxide is being changed from basic to acidic. Well, nature of oxyacids, if we consider oxyacids like HNO3, H2SO4, all these, in period if we consider like PCN, the strength will be increasing, like it will be H3BO3, HNO3. So if we see the strength is increasing, consider H2SiO3, H3PO4, H2SO4, 304, we will observe that the strength is increasing continuously. For the same acid, if we consider on increasing the percent of oxygen content, what we will observe is the acidic nature increases. On the other hand, if we study about the nature of hydrides, What we hear in the nature of hydrides? Ammonia has two HF, three things, three acids we are considering. On moving left to right in a period, we see that ammonia is a base, water is neutral, and HF is an acid. So, on moving left to right, acidic nature is increasing. On the same, if you see our pH3, H2H, HCl, same trend will observe acidic nature is increasing. Next we'll observe about the next we'll observe about the anomalous. Why the elements of second period show anomalous behavior? What is the reason? There are some reasons why it is showing anomalous behavior. Like we observed in electron affinity, the electron affinity of the third group is more than second group, and many other properties. So what's the reason behind that? The first reason is the small atomic radii of the period of the elements of second period. Next is the high EM of those elements. Next is the non-availability of vacant d orbitals. Non-availability of vacant d orbitals. Second is high charge to radius ratio. Also, their property varies. That one more reason is behind it is a tendency of carbon, nitrogen, and oxygen to form multiple bonds. So this is also one of the reasons.